Hey guys, welcome back to the TTA Performance YouTube channel. And today we're looking at an 81 301 turbo block, or I should say it's actually an 81 non-turbo that we picked up. Now this is not the one from the previous video. Ironically, a couple weeks after purchasing the one that was in the other video where we were pointing out the differences in the 81 non-turbo 4-barrel application, another one showed up. And it was local. I ended up buying it. It's almost a twin of the first one from the video. This one here actually has 56,000 miles on it, was in a running car a couple months ago. Unfortunately, the car had gotten into an accident. They were rebuilding the car as a Pro Touring. So we picked up the engine. So we tore it all apart, and we're actually going to be using this to test some parts on it in a completely stock configuration. And I'll get into that in more detail a little bit later. But right now, we're just going to tell you, just want to go over what we have. So this is, again, an 81 non-turbo 4-barrel 301. It is a turbo block, and it has 56,000 miles. And as you can see, the non-turbo does not have the dished pistons in it like the turbo engine does. These are completely flat top pistons. Yes, they have a chamfer on the outside edge. This is roughly 8-to-1 compression. Depending on some literature that you read, it's anywhere from 8 to 8.2 to 1 on the compression ratio. But we're going to be using this. It'll work just fine with boost because we're actually going to convert this engine to a turbo to test a few things. So one of the things, the main thing that we're going to be testing is head gaskets. Why are we testing head gaskets? Well, we recently found out that Felpro and Victor are no longer making head gaskets for a 301. Now, there was no difference in the gasket between the turbo and the non-turbo. But for the longest time, we were buying Felpro gaskets and we were modifying them by adding additional cooling holes. Well, Felpro discontinued it. They're no longer available. Kind of hard to find any new old stock that's out there of it. So we decided to take upon ourselves and actually design and have a company make head gaskets for us. Now, these head gaskets, besides the cooling holes being added like we were doing on the Felpro ones, they're already put into this. But one of the things that we had to kind of deal with was that the company can only make a perfectly round cylinder bore. Now, if you were to look at a Felpro gasket, the Felpro gasket had a smaller cylinder bore and fire ring, but it was egg-shaped near the exhaust valve. And that's because the combustion chamber was actually a little bit wider than the actual bore of the block. And so in order to do that, we actually had to make the cylinder bore a round diameter, and it had to make it to what the widest point was on the combustion chamber. So we ended up with a much larger bore. The other thing was, once you go larger on the bore like that, you tend to create more volume in the cylinder near the combustion chamber, and it could potentially drop the compression ratio a little bit. So to combat that, we actually had the gasket made thinner. And so this is going to be a prototype gasket that we're going to test. So as you can see, it fits onto the block, no problem. But yeah, the bore diameter is bigger than the actual cylinder itself. This is a little warped, but so we're going to bolt on these head gaskets, and we're going to test it on this engine. Now, as far as what we're testing, so I'm looking for, I don't want to say worst case scenario, but I'm trying to not give it a chance and see how well it can hold in a severe situation or in the worst case situation. So basically, we already have half a point more compression, which is give or take with the larger cylinder bore. We're going to be converting it to turbo. We're going to be putting a completely stock turbo on it. This is not an upgraded turbo. So it's actually a low mileage turbo that we have that's actually in pretty decent shape. So we're going to be putting that turbo on it, stock intake manifold, stock exhaust manifolds. Everything on it is just going to be off-the-shelf good parts that we have. Some of the things that we did do is we put the high volume oil pump that would be the oil pump that would be found in a turbo engine. So we did put a new oil pump in it. We also put a double roller timing chain in it because the timing chain was pretty sloppy. The cam that's in it, stone stock, 56,000 mile flat tappet cam straight from Pontiac. Didn't do nothing with it. It looks to be in great shape. That's back in it, or actually we never even took it out. I never even pulled a bearing out of it, so I have no clue what the bearings look like. We're just going to wing it and go with it and see how it works out. Everything's been cleaned up. We're going to bolt on the heads. Heads are the heads that came off this engine. Nothing's been done to them. There's no porting, there's no unshrouding, there's no anything. It literally took them off, cleaned off the head gasket, and we're going to bolt them right back on. Other than that, everything else, I mean, just to make sure we had good parts, we got a good water pump on it. The timing chain cover's in good shape. It does not have a baffled oil pan, so anybody out there that has a non-turbo engine, 301 4-barrel that is a turbo block, be aware that the turbo cars got a baffled oil pan. Basically, it's just a flat piece of metal that's kind of going around the oil pump area by the sump. So this one does not have that. Not going to be a big deal because we're just going to put this on an engine dyno. And what are we going to do with it on the engine dyno? Well, we're going to run it with boost. We're going to make sure the head gaskets hold, but we're going to push it. We're not trying to blow it up. I didn't even gap the rings in this thing. It doesn't even have an opened up ring gap. This thing is completely stock. So what we're hoping for is that we're just going to throw some boost at it. We're going to make sure that the head gaskets hold. Maybe we'll throw some water injection on it, turn the boost up 13, 14 pounds. I might even put a stock downpipe on it just to, again, we're going to see how much back pressure it has too. So I do want to run a few things. We're going to put a back pressure port in the up pipe. We're going to measure, some people call it turbo drive pressure, but basically back pressure in the manifolds at different boost levels. We're going to see what the vacuum reading is at the plenum right in front of the compressor of the turbo. We're going to see what that does. What else are we going to do? And again, we'll be running up the boost on it and see, and probably maybe have a few other gauges on it, testing some certain things. But with that, let's get the heads bolted on, and once it's all put together with all the parts, we're actually going to run it on our stand, our engine stand, just to kind of make sure everything's good oil pressure, dial in a carburetor, all that stuff, and get it ready to put on the dyno. So we'll get it all together here. Okay, so we got the heads bolted on with the new head gaskets. One of the other gaskets that got discontinued from Felpro and is no longer being made is actually the intake manifold gaskets for the 301. So we're having those made also. So here's a prototype set for the intake gasket. It is cut out of a very thin gauge steel, has a gasket material on it. It's very, very similar to the Felpro gasket, almost identical. So we're going to install these too and test these. I really don't see a problem with these gaskets at all. But we'll get these glued on, put the intake on, and start buttoning up the rest of it. Alright, what we got going is it's all stock right now, stock downpipe, and here we have vacuum at the plenum and back pressure in the up pipe of the turbo. Get it warmed up here, we're going to test it all stock. It even has a muffler on the stock downpipe. let's go over what happened at the dyno. So the dyno was not intended to be a, hey, how much horsepower can we get out of this? It was more of a durability test on the new head gaskets that we're going to be offering, and they work great. Didn't have a problem with them. Everything was working flawless. So definitely a good thing happening there. We'll be putting the head gaskets up on the website soon, along with the intake manifold gaskets. But while we're on the dyno, it's like, hey, let's test a few theories or whatever. Let's see about some of my other products that I've already had out for a long period of time. Let's just document exactly what kind of gains we get from it. And maybe even experiment with some other things to see if there's any benefits to making some changes or, like tuning and things like that. So I've got my notes here. So the first thing that we did, obviously, we had put that stock downpipe on it. It had a chambered muffler, kind of like a Flowmaster muffler on the end of it. It had the back pressure gauge tapped into the up pipe. First interesting thing that we saw, a lot of back pressure, a good amount of back pressure. And what had happened, the first run that we made, I had a manual boost controller on it, but I thought I had it turned down all the way. There might have been a small amount of tension on the manual boost controller to where it was kind of raising the boost over what I thought should be stock. I like to run them somewhere around 7 or 8 pounds. It was just a tick over 10. And maybe it was a back pressure thing that was causing it to kind of drive the turbo a little bit more. I'm not sure. But when I was running it with 24 degrees of timing, which is the factory setting, the maximum amount of timing on an 80 distributor, we actually heard it get into a little bit of detonation on the dyno. So we turned the timing down 2 degrees and put it at 22 to kind of get rid of that. Now, we did have water injection on it, but it was not on at this point. Got it down to 22 degrees of timing. There was no more detonation. It roughly made about 197 horsepower, like 290 foot-pounds of torque. The back pressure was the big eye-opener for me. At that 10.5 pounds of boost, the back pressure was like 26 pounds. So we were well over a 2-to-1 pressure ratio. It was like 2.5-to-1 pressure ratio going on there, which is not good. And rather than make any more runs with it, or even trying to look at the boost controller to see if I could lower the boost at all, I right away went to my 2.5-inch downpipe and no muffler. So we put that on right away. I did look at the manual boost controller and unscrewed it even more. I don't know if it made a difference or not. Basically, though, the boost was less on the next run with the big downpipe. So what's interesting is that had the big downpipe on it, made about 8 pounds of boost, but the back pressure was a lot less. We were down to like 15 psi of back pressure on 8 pounds of boost. So now we got the pressure ratio down to 2-to-1 or just slightly under 2-to-1. And it actually made more power, and it was under less boost. So we actually got it up over 200. It went like 211 horsepower, and we went over 300 foot-pounds of torque. So it was like 305 or something like that. So then, like I said, it was at 8 pounds of boost. So then we were still at 22 degrees of timing. We didn't mess with the timing. We kind of left it there as we were just basically making one change at a time. So we were just increasing the boost from there. So then I thought I had made a significant change to the boost controller, but it only raised it a little bit. We went from 8 pounds with the big downpipe. Then we got it up to like 10.5 again. The 10.5, according to my notes, let me check them real quick here. So 10.5 psi of boost. We actually made 230 horsepower with it. And the back pressure was still in that 15 psi range. It really didn't change much. Torque was up to 334. No water injection yet. So then the next test, I upped the boost again. This time we got it up to 12 pounds of boost, and we turned the water injection on. Water injection was coming on around 9, and this is washer fluid, water with methanol mixed in it. So still at 22 degrees timing. got a little more boost pressure in it, and back pressure started to come up. So now we're at 12 psi of boost, but now we got 20 psi of back pressure. So it's going up with the boost like it should. And horsepower was up. It was up to 237, and torque was up again 340. Now it was up to 348. So we're making some decent changes or decent increases in power just by adding the boost. Tried to add more boost. We went to 13 psi, made 244 horsepower. Torque was about the same though. And then we did try for 14 psi, but at 14 psi, it seemed like it kind of started to fall off a little bit. So I'm wondering if at 14 psi, if things were starting to get a little diluted, because the back pressure did come up considerably. At 14 psi, we actually had 26 psi of back pressure. So again, still at that 2-to-1 ratio, but the ratio is good, or well, better than the stock downpipe, obviously. But that 2-to-1 pressure ratio, I think you start getting into a point where it's not so much the ratio, but the actual amount of back pressure. So 26 psi of back pressure, I think we were starting to really dilute the mixture in the cylinder during the overlap period of the camshaft. Now, granted, it's a stock camshaft, so the overlap period is very short. There's not a lot going on, but when you have that much back pressure in the exhaust, it tends to stick around, and you get this, what I call the EGR effect, basically exhaust gases that were kind of staying in the cylinder. And I think that kind of killed the power a little bit. So then we decided to kind of go after the timing side of things, because we were still at 22 degrees. So we added 2 degrees of timing, we brought it back up to 24. It started to make power again, started to get into it. The best that we did, we actually pushed the timing farther than I would be comfortable doing in an in-car application. Normally, I don't go above 24 degrees. To me, that's pretty safe for the timing. It's worked successfully with all kinds of cars, my cars, customers' cars, and things like that. So we actually did try to push the timing a little bit. Figured, number one, we'll see if it makes any more power. Number two, this would raise cylinder pressures to, again, durability testing for the head gaskets. And we did put 27 degrees of timing in it, and it made the most power. It made 249 horsepower and 374 foot-pounds of torque. So I really like that one. And then we tried to put 2 more degrees in it. We tried 29 degrees of timing, but then it started to drop off. And actually, it tended to show a little bit of blow-by. Not like it got hurt, but I'm wondering if we stressed it so much or added so much heat that the rings had trouble sealing, or something, because we were doing like back-to-back runs with it and stuff. And it started to puff a little bit out the valve cover breather. Not like it had a dead hole. It still ran great. We had shut it off, let it cool down, fired it back up, and the smoking went away. So we might have stressed the rings a little bit on some of those runs. But still, I mean, that was a lot of information going on there. We learned some things. To me, the takeaways were number one, again, head gaskets work. That's great. Intake gaskets work. Awesome. The biggest takeaway was, man, downpipe makes a difference. Freeing up the exhaust and getting that bigger downpipe on it really helps out in the back pressure, especially even when you're just dealing with a stock turbo. That was a big takeaway. The water meth injection is mainly there so that you can maintain your ignition timing and keep the timing up. That's helping. And it works, as it's supposed to. And then we also had a vacuum gauge on the plenum, just like I was doing with the other engine on the dyno and my personal car, seeing if there was any vacuum in front of the turbo. Well, there was none. Maybe there was 1 inch of vacuum when we got into the higher boost, but that tells me that the plenum is not a restriction when you're dealing with a stock turbo, with a stock compressor wheel and everything. The compressor wheel on a stock one is so small that the plenum is not a problem. I think once we get into the upgraded turbos and putting a bigger compressor wheel in it, we're turning the boost up higher, we're trying to flow more air. Yes, I port the plenum to match usually, but I think it gets to a point where when you're really starting to push these things, and starting to run some pretty high boosts and stuff, you're getting into a point where you just can't flow enough air through the plenum. But I'm working on that. I got a design down that I'll show you guys as soon as I test it. And it's kind of neat to actually, test a stock 301 turbo. I mean, I've never done that before. Everything I've always done was modified in some way, bigger turbo and whatnot. It would have been great to maybe try a bigger turbo on it and see what would happen. I think if there's such a benefit and a gain to having the larger downpipe, then the larger turbo is definitely a big gain. And we've seen it too. We've seen back pressures come down because of the bigger turbo. I always feel that putting the bigger turbo on even a stock engine, the car just feels more responsive. It feels like the engine can breathe. The throttle response seems better, but definitely a benefit, especially when you're freeing up the exhaust side of everything. But for that, I hope you guys enjoyed the video, and thanks to everyone out there that subscribes and likes and shares and everything. That's much appreciated. And well, we'll see you next time. Thanks.